Hello students, A2 chemistry chapter is electrochemistry, lecture number 11. In this lecture we are going to talk about what is a fuel cell, what is the composition of fuel cell, what are the chemical reactions that occur when a fuel cell it is producing electrical energy, and what are the relative advantages and disadvantages of fuel cell compared to the other cells. But before that, you must also remember that fuel cells nowadays they are used very commonly in our daily life. Now, what are the different uses that you can keep in your mind whenever you are asked about the daily life uses of fuel cell? You can remember fuel cells they are used both as a primary source of power as well as backup power source for many commercial as well as industrial purposes. So this can be one use that you can keep in your mind. Beside that, fuel cells are also used in different residential buildings, especially those which are located in some remote or inaccessible areas. In those areas, the electrical energy produced by fuel cell it is a best source of power. Likewise, nowadays we are also using fuel cells to power vehicles, for example, forklifts, automobiles, buses, boats, and submarines. So these are some uses nowadays that are based on fuel cells that are based on the electrical energy produced by the fuel cell. Now, particular question that I told you in the previous lecture that can be asked about the composition of fuel cell, and composition of the fuel cell it is more important. Why? Since composition helps you to write down balanced chemical equations for the reactions that can occur in a cell. So let's start with the composition of the fuel cell. Composition means you must know what is anode and cathode made up of, and what is the electrolyte that is used in a cell. Now in case of fuel cell, you must remember anode and cathode they are made up of graphite. They are made up of porous graphite walls, and these walls, graphite walls, they are coated with nickel and nickel oxide. Nickel and nickel oxide they are used as catalyst to increase the rate of reaction. Electrolyte that is used commonly in the fuel cell it can be of two different types. Sometimes we use any strong alkaline solution as an electrolyte, or sometimes we can use strong acidic solution as an electrolyte. So we can use both HCl solution, or we can use sodium hydroxide NaOH solution as an electrolyte. But one more thing that you must remember in case of fuel cell, besides this composition, we always use a fuel. Since the name of the fuel cell it indicates, we must use a fuel for the production of electrical energy. So what are the common fuels that we use when fuel cells they generate voltage or electrical energy? The common fuels that are being used nowadays, some examples you can remember. For example, most common example you can say hydrogen gas, it is a common fuel used in the fuel cell. Methane gas can be used, and you can also remember one liquid fuel that can be ethanol. So these are examples of some fuels that can be used in a fuel cell for the production of voltage or electrical energy. So this is the composition that you must remember. And next thing, I can show you a fuel cell how it looks like, a simplified diagram of a fuel cell. This is a simplified diagram of the fuel cell. Okay, you can see in this diagram that look at this portion. This is one wall of graphite, this is another wall of graphite, and you can see this cell it has been divided into three compartments by using these two walls. Both of these walls they are made up of powdered graphite, so they are porous from where ions they can migrate. This is one wall made up of graphite coated with nickel and nickel oxide. This is other wall made up of graphite coated with nickel and nickel oxide catalyst. Now these two graphite walls they have divided the cell into three compartments. You can see this central compartment, this one, this central compartment it is known as electrolytic compartment. This central compartment, it is known as electrolytic compartment. While this compartment in which we inject the fuel, like you can see we are injecting hydrogen gas, so this is known as anode, because fuel is always injected into the anodic compartment, and this compartment where we inject oxygen or we inject air, this is known as cathodic compartment. So you can see this simplified diagram that by using graphite anode and cathode, the cell has been divided into three compartments. Central compartment where the electrolyte is present, anodic compartment where fuel is injected, cathodic compartment where air or oxygen is injected. So this is the composition of the fuel cell and how it can perform its function. One more thing, remember, in your exams you are not asked to sketch or to label this diagram, but this diagram that will be provided to you in the exams, it is very important. Why? Look at this diagram right now. You can see in this diagram what is the electrolyte. You can see there are hydroxyl ions present into the central compartment. What does this mean? In which case, in this case, you are using which electrolyte? You are using a strong alkaline solution as an electrolyte. So basically, whenever you have been given this diagram, it is an indication that paper setter is interested. You should write down chemical equations in which medium. If in the central compartment you see some acid H ions are present, you are supposed to write down chemical equations for the reaction that can occur in the acidic medium. In this diagram you can see OH ions are present into the central compartment, so it means you are supposed to write down equations for this for this fuel cell using alkaline medium. So this is the purpose of giving diagram in your exams. If diagram is not available in the diagram, then you have an open option. You can write down chemical equations for any type of electrolyte. You can write down for acidic medium as well as for alkaline medium. You will see, I will show you how to write down the chemical equations both for acidic as well as for alkaline medium. Okay, moving on. Next thing, how to write down chemical equations if fuel is hydrogen. Okay, we will do practice for writing chemical equations for the reaction using two different fuels. I will give you an idea. For hydrogen, it is very simple. For any other fuel that contains carbon, the chemical equations are slightly different. So I will give you an idea how to write down equations for hydrogen as well as for any other fuel that is containing carbon. Okay, look at if fuel is hydrogen. As I told you, fuel is always injected into the anodic compartment. Into the anodic compartment. At anode, always remember oxidation takes place. So when at anode oxidation will take place, what does this mean? It means that hydrogen will be oxidized into H ion. This is oxidation. And first of all, we are going to write down equations if fuel is hydrogen and you are available with acidic medium in the central compartment of the fuel cell, then you are supposed to write down these equations. So what will happen at anode? Always oxidation of the fuel will take place. And I have told you hydrogen gas, when it is oxidized, what happens to hydrogen gas at anode? It is oxidized to hydrogen ions by loss of electron. So what equation you can write down? You can write down H2 producing H ion by the loss of electron. So this reaction takes place at the anode if the medium is acidic. Now what happens to these H ion and electrons? These H ion and electrons, they reach at the cathode. At the cathode, I told you, we inject air or oxygen. So at the cathode, reduction will take place. These H ion and electrons, they will combine with oxygen at the cathode. So what will happen? These H ion and electron, they will combine with oxygen, and what will be produced? Water will be produced. So this equation you can write down at the cathode. H ion plus electron will combine with oxygen. Oxygen we are injecting at the cathode coming from air. So this oxygen plus H ion plus electron, you can see it has become water. Now, if you look at the first equation, it is oxidation. The second equation is reduction. If you are asked in the exams to write down a net redox equation for this reaction, it is not a problem. Simply, you will add up both these equations, but before adding up, you must cross out number of electrons. You must balance out and you must cross out number of electrons on both sides. So, right now, number of electrons are equal. So obviously simply we will cross out the electrons, and we will also cross out H ion on both sides. Why? Because number of H ion is also equal on both sides, so this will also be crossed out. So what will remain behind? The final equation that you will see, it will be H2 plus half O2 giving H2O. This is the final equation for the combustion of hydrogen gas in the fuel cell when the medium is acidic. One thing always remember, whenever you have written an equation for oxidation and reduction in the fuel cell and you are interested to write an equation for net redox reaction, always remember the final equation will be representing the process of the reaction of combustion of that fuel. That's it. Everything else present in the chemical equation of oxidation and reduction will be crossed out. I will give you some more examples, you will see, but you must remember whenever you are asked to write down a net redox equation, the net redox equation is always the combustion of the fuel being used in the fuel cell as a fuel. Okay, moving on. Now let's suppose the fuel, it remains hydrogen, but you have been given alkaline medium. So what will happen in that case? Look, at anode, again oxidation takes place. No problem with the oxidation. At anode, always oxidation takes place, and right now we are having hydrogen as a fuel. So hydrogen, when it will be oxidized, it will produce H ion and electron. But what happens to these H ions? Since the medium is alkaline, these H ion, they will not remain H ion. They will be neutralized, they will be trapped, they will be attracted by the OH ion. So what can happen in this case? When you want to write down equation at the anode, you will write down H2, but you will write down H2 will combine with OH ion. Since there are two H ion will be formed, so two OH ion, they will combine with H2, and 2 mole of water will be produced by the release of 2 mole of electrons. So I think it's very simple to understand what has happened. Simply look at the first equation that I have written in the acidic medium. The H2 molecule, they have been oxidized to H ion, but H ion, they are quickly neutralized by the OH ion since the medium is alkaline in this case. So 2 H ion plus 2 H ion, they have produced 2 mole of water by the loss of 2 mole of electron. So this is the slightly different equation at anode. You can see when the medium is changed. Now what will happen in this case at cathode? As you know, at cathode we are injecting oxygen air. So in this case, oxygen will combine, will react with water along with the electrons. So what reaction will take place in this case? At the cathode, oxygen, it will combine with water plus electrons to produce hydroxide ions. This is a very common equation we used to write down. We are writing from O levels, but in reverse form. In this case, I have written this equation for the production of OH ion. In O levels, you people used to write down this equation for the formation of oxygen from hydroxide ion. Now what you can do, if you wish to write down net redox equation, you can write down, no problem. Simply electrons are equal. What you can see, if you want to write down the net redox equation, you can make it its redox equation quite easily. What you can do, simply cross out the electrons. Electrons are equal. Cross out the number of mole of OH ion since they are equal, and also you will cross out 1 mole of water from both sides. Why? Because there are 2 mole of water on the right hand side, 1 mole of water on the left hand side. So what will be the final equation that will left behind? You can see the final equation, whether you are using acidic medium or alkaline medium, the final equation will remain behind, will be simple combustion of hydrogen fuel. So you will get H2 plus half 2 giving H2O. So always remember, whether we use acidic medium or alkaline medium for a fuel in the fuel cell, final redox equation is the combustion of that fuel, nothing else. Let me give you one more example. Now this time I am choosing a fuel containing carbon, and the simplest fuel I am selecting, it is methane, CH4. So based on methane, At the most, what other fuel can be given to you in your exams? Ethanol, liquid, C2H5OH. As I will tell you the method to write down equations for the oxidation of methane fuel, likewise you can write down equations for ethanol liquid yourself. Now let's start with the writing equations for the acidic medium. For the acidic medium, if it is available, how methane it will undergo combustion in the fuel cell. Okay, if the acidic medium is acidic, fuel is methane, we are injecting methane at the anode, so at the anode oxidation will take place. So what you must remember, how you should start writing equations for a carbon fuel. All the carbon present in a carbon fuel, first of all it will be converted into carbon dioxide. So you will start writing, making equation how all the carbon present in a carbon fuel, change it into carbon dioxide. Like in this case methane, you will get 1 mole of carbon dioxide. Like if suppose after this you can write on yourself, if it is asked to write on equations for ethanol fuel, how many mole of carbon dioxide you will produce in that case? 2 mole of carbon dioxide, because there are 2 carbon. So first of all the carbon must be oxidized to carbon dioxide. This should be your first step. After that, what will happen to the hydrogen? Hydrogen would become H-ion, as I have done in the previous case when fuel was hydrogen. Now look at this, CH4, it has combined with water plus giving CO2 plus 8 H plus 8 electron. Now what has happened, how we have balanced this equation? We studied rules for balancing equations in AS redox reaction. Exactly that method I have used to balance to complete and balance this equation. What I have done, look at this. Carbon, there is one carbon, I have converted that carbon into carbon dioxide. Carbon has become carbon dioxide. What next? How many oxygen atoms are on the right hand side? When carbon dioxide was produced, it was produced having 2 oxygen atoms. How oxygen is balanced? By adding water. How many mole of water we added on the left hand side? We added 2 mole of water. So when we added 2 mole of water, oxygen is balanced, but how many hydrogen we got total on the left hand side? 4 plus 4, 8 hydrogen we got. So what does this mean? When there are 8 hydrogen, we would get 8 H ion. All the 8 hydrogen, they will undergo oxidation at anode. 8 H ion will be produced, and when 8 H ion, that is why 8 electron will be released by 8 mole of H atom. Now this is very simple. Likewise, if you wish, you can write down equations for ethanol. What you will have to do, how you will have to do, simply there are two carbon in ethanol, so you will produce 2 mole of CO2, and then you will start balancing oxygen and then hydrogen and then electron accordingly. Exactly same method will remain. Now what happens at the cathode in this case? Carbon dioxide, it is the stable product, it will be released. But what will happen to H ion and electron? H ion and electron at the cathode, they will combine with oxygen. And when H ion and electron, they will combine with oxygen, they will become water. Now this is a complete equation, and if you look at the color of the equation that I have chosen, it is blue. Exactly same equation we have written for the acidic medium when fuel was hydrogen. So the color of the equation is indicating that the this equation does not change. If medium is changed, then equation at cathode, reaction at cathode is changed. If medium is same, the fuel might be hydrogen or methane or ethanol, the chemical equation for the reaction at cathode will remain same. Now if you wish, you can make a net redox equation for this reaction yourself. Simply what you will have to do, before taking a sum of these two equations, you will have to multiply the second equation by 2. Why by 2? Because there are 4 mole of electron. In the first equation there are 8 mole of electrons. So that is why what we will do, we will multiply the second equation by 2. When you will multiply, there will be 2 molar there will be 8 mole of electrons in both these equations. Electron will be cancelled, H ion will also be cancelled, and 2 mole of water will be cancelled on the left hand side, because on the right hand side we would have 4 mole of water. So just make a try, give it a try, and write down a net redox equation yourself. Remember, the final redox equation that you will get to know, that you will get, it would be Simple combustion of methane, CH4. That's it. Okay, moving on. If you have completed this, we can write down our equation for alkaline medium. Now this time what will happen? The reaction at anode will remain same that we have written in the previous case. CH4 plus 2H2O giving CO2 plus 8H ion plus 8 electron. But what would happen to 8H electrons? 8H ion, they will be neutralized. 8H ion, 8H ion will be neutralized by 8 mole of OH ion because the medium is alkaline. So that is why you can see I have added 8 mole of OH on the left hand side, and we have balanced all the other equation. It remains same, no change. Now at the cathode, this time equation will be changed. Why? Because the medium is alkaline. So what you will have to do now, you will have to use water and electron. Water and electron, they will combine with oxygen to produce hydroxide ion. Look at this equation is exactly identical to the equation we wrote for when fuel is hydrogen for the alkaline medium. Now if you wish, you can make its net redox equation, that is not a problem. You can multiply the second equation by 4 before taking a sum. Electron will be cancelled, OH ion will be cancelled, even the water from the left hand side will be cancelled. So the net redox equation, whether the medium is acidic or alkaline, it will remain same. Now likewise, I think you can practice yourself, you can write down equations yourself for ethanol liquid. If you have some problem, you can tell me in the comments. I can give you the solution for that, but that's simple, that's not a problem. Okay, moving on to last thing that can also be asked in your exams. What are the advantages and disadvantages of fuel cell? Advantages of fuel cell that you can remember: it can produce high voltage compared to other cells, doesn't cause any pollution problem, efficient, more voltage, efficient voltage, and gaseous fuel. Now gaseous fuel, remember, it is an advantage as well as it is a disadvantage. Why gaseous fuel? It is an advantage because large volume of the gases can be stored in small cylinders under pressure. So gases can be an advantage since large amount of the fuel can be stored in small cylinders. But how it is a disadvantage as well? Gaseous fuel can be a disadvantage because gases can explode under high pressure. So explosion may occur when pressure is applied. When pressurized gases they are transported, they can explode. So that is a disadvantage as well. Beside that disadvantage, you can remember large size, greater mass, gaseous fuel, and obviously these type of cells, they are expensive. So this is all about fuel cell. This information you must remember, but keep in your mind you must practice equations for the ethanol because that is another type of fuel that can be asked. I hope you would have enjoyed this lecture. Thank you for your time.